Right, so in this lesson today, you're going to be looking at magnetic fields, and we're going to be looking at how we can visualize magnetic fields around an object, because the issue with a magnetic field is it's invisible. So what a magnetic field actually is it's the area around a magnet where the force will act, and this is the same for any field in physics. So when we've looked at electrostatic fields before, when we've been looking at electrical and magnetic fields in terms of electromagnetic waves, anything like that, what we're talking about with a field is a region around something where a force will act. So a different example might be a gravitational field, and the gravitational field around the Earth is the field around the Earth where the Earth's gravitational pull will pull something towards the Earth. And for a magnet, this force will act on other magnets or magnetic materials. And we can use this to visualize a magnetic field. So first off, we can draw it, and it should look something like this one down here. Okay, so when we're drawing a magnetic field, it's going to look like this. Okay, so this being a magnetic field, but to actually see that in real life, this is what we draw it like. But to see it, we're going to draw something like this, or we're going to make something like this, where we can use something like iron filings, so something that the magnetic force will act on as a magnetic object, to show where the magnetic field is. So the aim of today is that you're going to be filling in the little booklet that you've got, and you should be pausing the video when you need to fill bits in as I go through a couple of little practical things to show you what magnetic fields are like. So before you start though with all that, I want to do task 1, which should be a little recap of stuff that you did last lesson. Okay, so just to check that we understand the basics before we move on to the magnetic fields bit, which is a little bit more complicated. So if you do that now, and then I'll go pause the video, do that first task, then play again, and I should start going through how we show a magnetic field.
Okay, so we're going to have a look at the magnetic field around a bar magnet now. So this is your first demonstration, and we want to see the magnetic field, or try and visualize the magnetic field around this bar magnet, which is not easy because you can't see a magnetic field, because a magnetic field is just the area around the magnet where the magnetic force will act, okay, as we kind of touched on last lesson. So it's going to be very difficult for us to actually see where that magnetic field is, because magnetic fields aren't visible to us. Okay, they don't give out visible light, they don't reflect any light, so we can't see them. But we can show them because it's the area where they have an effect on objects that they would have an effect on, so magnetic objects. So one way we can do this is by using iron filings. Okay, so iron filings are just tiny, tiny little pieces of iron, that are able to move in a magnetic field quite easily. Okay, so I've got a clear sort of screen here, which I'm going to put over our magnet, just mostly to stop this making a bit of a mess, and the cleaner's shouting at me. So I'm going to sprinkle over this now our iron filings. So I've got a little pot here with some iron filings in, and I'm going to sprinkle them around it, and we'll see from seeing where they go, we can start to look at the magnetic field around our magnet. And you'll start to notice instantly where most of the iron filings are starting to go. Okay, you can see that they are concentrating at the ends of the magnets, the poles of the magnets. Okay, because the poles of the magnets are where we have the highest magnetic field density, or density of magnetic field lines. Okay.
From our magnet that we've got here, then we can start to see, using our magnetic field lines, that we can start to see our magnetic field lines using the magnetic particles that we've put around there, so the iron filings. So because of the shape they are taking, we can start to see where these magnetic field lines will be. So if you remember, we've got a north pole on this side and a south pole on this side, then we can start to see how the magnetic fields are coming out of this. So we can see that they are coming and we can kind of follow the lines where they're going. And we can see some are just going straight out of the North Pole and some are going straight out of the South Pole. But because of how we draw magnetic field lines, we draw them out of the North Pole going into the South Pole. But more importantly, we can see these ones, and you can kind of follow them going round here. So you can see these magnetic field lines going something like this. It's not perfect, but going somewhere around here, maybe into this side. Okay, and we can draw the magnetic field lines where they are going. So some are going to go right out here and maybe come back down in here like this. Okay, you've got these ones that are going closer. And we can draw these on. Okay, so we can see where the magnetic field is using our iron filings. So I've used the iron filings to actually show, to represent the magnetic field and to kind of show that up around the magnet, because obviously otherwise you can't actually see it.
Okay, moving on to our second demonstration now. We're going to have a look at how we can actually show the direction that the magnetic field is travelling. So far we've kind of said that you just take it as a given that it goes out of the North Pole and into the South Pole. I'll just label those on there for you. But you know, we can't just say that that is definitely true. And this is kind of arbitrary because it is just the poles of the magnet are kind of made up to fit with what we say is north and south on in terms of the Earth's magnetic field. But we can use a compass to show this. Okay. Now, if I take the magnet away for a second, obviously the poles are still drawn on there, but if I just leave my compass, and I'll put a couple on there just to kind of show you this. If I leave my compasses just on the desk, they will always point north. So in my classroom that I'm recording this in, north must be this direction because the compasses are pointing that way. And that is because if there is no strong magnetic force around the magnet, so just move my magnet past them then, around the compass, the little tiny needle on the compass is actually a magnet itself, with this pointy end being the North Pole, and this end, the South Pole, and this end being the North Pole. So these point towards the poles of the Earth, okay? So this one points towards the North Pole of the Earth, which is actually, this is a North Pole of this magnet, because the North Pole of the Earth, as you know it, is actually the South Pole of the Earth's magnetic field, which we'll go through on another day, but it's a little bit confusing. And so if there's no other magnet around it, that is the strongest magnetic field around. Okay. So if I move a magnet, if I put my magnet back where it was before, okay. Oh, that's the wrong way around. So if I put my magnet back where it was before, I can now see that this will affect the compass that I've got here. And as I move the compass around, I can see that the needle points in different directions. And I can see that first off, it goes, I'll just draw a little circle on here to kind of show you this.
So if we have our compass in this position here where we just saw that it was, we can kind of show what direction the magnetic field is going in. So if you saw on the video that I just showed you there, the magnetic field was pushing the compass, it was pointing this way. So we can see the direction it's going because it's pointing out of the North Pole. Okay, so I'll just put a proper arrow on there actually. So we can see that it's going this way out of the North Pole. And as we move that around, it starts to turn around. So when we put it down here, it was pointing like this way. Okay, and then we put it near the South Pole, it pointed into the South Pole. And we can kind of build up a picture of that. And this is what you're going to do on your diagram that you've got. So we get a picture of where these magnetic fields are pointing. Okay, and it kind of shows us what direction the magnetic field is going in. So it kind of points out of the North Pole all the time and into the South Pole. So if we have one there, it's probably going to go straight up. Move that one out a bit. But yeah, what you need to do on your little task that you've got then is to just draw arrows showing where the magnetic field will be pointing, remembering what the field lines are going to eventually kind of look like in terms of going out at the North Pole and into the South Pole. And again, so if you imagine these magnetic fields coming around here, okay, we're going to get one coming out of here and into there, like that, and like this. The advantage of using the compass over the magnetic iron filings is that while they both can show where the field is, and the the iron filings are really good at showing the density of the field because it shows where it's strongest and weakest. This is better because it shows you the direction the field is going in as well.
All right, finally we're going to have a look at, I think it's task 4 on your booklets, and it is the third demonstration that I'm going to show you. So this one, we're going to have a look at how different magnetic fields interact with each other. So we can see here, we've got again our magnets set up, and we have got, if I just colour my pen again, I'll use green again. I've got a south pole on this side and a north pole, and then another south pole and a north pole. So here I've got opposite poles, and they should be attracting each other. Now the only reason they're not pulling each other together at the moment is because I've blue tacked them to the desk, okay? So I've just blue tacked them to the desk so I can show you how the fields interact without them actually pulling together. So there is a force at the moment trying to pull these two magnets together. So it's trying to pull them, this one this way and this one this way. So that magnetic force is trying to do that because it is they are attracting because they're opposites. Okay, so what I'm going to do is use my iron filings again to show where the magnetic field is. So you might be able to think about this before we start. Where's the magnetic field going to go? Now, we've said it already, it always goes out of the North Pole into the South Pole. But if you've got these two North and South Poles next to each other, think about what's going to happen, and we'll show you with this what we see. So I'm not going to worry too much about the sides, I'm going to worry mostly about the middle here, but I will sprinkle around the sides as well, just to show you. But we can see how concentrated the magnetic field is inside this little bit here. Okay, so
We can see then from this where our magnetic field is. So again, like we did with just the magnet on its own, the density of the magnetic field is clearly really high in the middle in between these two. Okay, so if we remember what our poles are again, so we've got a south pole here and a north pole here, then a south pole and a north pole. And in this case, we can see that the quickest route for the magnetic field to go from north to south is to go straight over from north to south like this. Okay, and while we still do have some going around the sides, pen's just changing colour, just like that and like this, and I'll just do those ones on, but you can draw more like you would do. Okay, the vast majority of the magnetic field is going to be concentrated in this middle, but you're going to get much more kind of concentrated in here than we would normally have, because it's attracting, and this shows us the attraction between the North and the South Pole. We can see that they're kind of trying to pull each other towards each other, that all that magnetic field is concentrated around this middle part.
okay, so I'm going to take a final look now at how these magnets act if you try and put them in the opposite way around to what we just seen. So this time we've now got the South Poles on the outside and two North Poles on the inside. So these two magnets are now trying to repel each other because we've got the same poles next to each other. And we can see that if again we use our iron filings to show where the magnetic field is going. And we can see that where we had all the iron filings pulled into the middle before, this time they're kind of being pushed out, especially if we kind of look up at the sides here, try and just focus on that a little bit. We can see how the magnetic field is being pushed out of here.
Right, we can see the magnetic field then being pushed out of the gap here, because we've got this time a South Pole and a North Pole, and a North Pole and a South Pole. So we've got the same poles next to each other, and therefore they're going to try and repel each other, and we can see the magnetic field repelling. So if you look closely, you can kind of see that it's just being pushed straight up here, and then eventually it is going to go around to the South Pole, but it's kind of being squashed up in this side, where it should be going normally. It's got that kind of curve going round here, but it's just been squashed up on both sides, okay, and being forced to kind of push outwards like this. So not in a wonky line like that, but being pushed outwards like that. So we can. This shows us that these two are being repelled, and you want to be able to draw a magnetic field going out like this, kind of being squashed up in the middle. So it's trying to force its way out of here. So this shows us that it's repelling, and you should now be able to complete both those diagrams on your bottom part of your booklet, the last little section where you're looking at the attraction and repulsion of the same and opposite poles. Okay, so that should be everything, and if you can send that through to me as soon as you've done it, that'd be brilliant, and I can see that we all understand everything we need to. Hope you're all okay, and hope this has helped you today.